Greetings to all the viewers who are watching this video. This is a participatory learning assignment for optimization technique. A topic for our assignment is saddle point in game theory. The team members are Rayyan Pasha, Shivani S, Sampurna Singh and Danish, belonging to BCA Cloud Computing 3rd semester. Coming up, we will look into max-min criteria, min-max criteria, saddle point, optimal strategy and value of game, followed by 2 problems related to the topics. Before we get into the sums to solve the related problems, we need to learn about the definitions of few important terms. The first topic is maximin criteria. The term maximin is made by combining 2 words maximum and minimum. In this criteria, the player who is maximizing the outcome or payoffs finds out his minimum gains from each strategy and selects the maximum value out of these minimum gains. This is a decision-making approach where a player focuses on minimizing potential losses. They identify the minimum payoff for each strategy, which is the worst case scenario, and then choose the strategy with the highest minimum payoff. This ensures the player selects the most secure option, prioritizing safety over higher but riskier gains. It's often used in uncertain or competitive situations. The next term is mini-max criteria. In this criteria, the minimizing player determines the maximum loss from each strategy and then selects the minimum loss out of the maximum loss list. It is a decision rule used by minimizing players to minimize potential losses. The player identifies the maximum loss associated with each strategy, which is the worst case scenario, and then selects the strategy with the smallest maximum loss. This approach ensures the player avoids the most severe losses, prioritizing cautious decision making in competitive or uncertain situations. A saddle point in a payoff matrix is a position that represents the equilibrium of the game, where the interests of both players are balanced. It is the value of the element in the matrix that is the smallest in its row, which is the best outcome for the minimizing player, and at the same time the largest in its column, which is the best outcome for the maximizing player. As we can look at the mathematical equation for saddle point, max I min j Vij. This is the value that the row player, maximizing player, considers the minimum payoff in each row, which is the worst case scenario for each strategy, and chooses the strategy with the highest minimum value. Whereas we have min j max I Vij. This is the value that the column player, which is the minimizing player, considers the maximum payoff in each column, which is the worst case scenario for their opponent, and chooses the strategy with the smallest maximum value. And if these two values are equal to VRS, it confirms the presence of a saddle point at position R, S. The saddle point ensures equilibrium because neither player has an incentive to change their strategy, as doing so would result in a worse outcome. It is a stable solution in pure strategy games. If no saddle point exists, the players may need to adopt mixed strategies. Coming up next, Sampurna Singh will be discussing on the rules for determining a saddle point.
Saddle point. A saddle point of a payoff matrix is the position of such an element in the payoff matrix which is minimum in its row and maximum in its column. Mathematically, if a payoff matrix Vij is such that minimum into Vij is whole multiplied with maximum is equal to maximum into Vij is whole multiplied with minimum is equal to VRS, then the matrix is said to have saddle point R and S. Rules for determining a saddle point. Number 1. Select the minimum element of each row of the payoff matrix and mark them by circle. Number 2. Select the greatest element of each column of the payoff matrix and mark them by square. Number 3. If these appear an element in the payoff matrix marked by circle and square both, the position of the element is a saddle point of the payoff matrix. Optimal strategy: the course of action which maximizes the profit of a player or minimizes his loss is called an optimal strategy. If the payoff matrix Vij has the saddle point R and S, then the players A and B are said to have R8 and S8 optimal strategies respectively. Value of game: the payoff VRS at the saddle point R and S is called the value of game, and it is obviously equal to the maximum and minimax value of the game. A game is said to be a fair game if minimax value is equal to maximum value equal to 0, and a game is said to be strictly determinable if minimax value is equal to V equal to maximum.
Hope you have understood and noted down the definitions as they are important for your summand examination. Let's move on to our example 1. Consider two-person zero-sum game matrix which represents payoff to player A. Find the optimal strategy if any. Here is the matrix for the given problem. First, we need to find the row minimum and the column maximum of the matrix. The row minimum of the matrix should be marked as circles. First row -3, second row 0, third row -4, and we'll mark the maximum value, that is 0. The column maximum of the matrix should be marked as squares. First column 5, second column 0, third column 6, and we'll mark the minimum value, that is 0. As the maximum value and minimax value are same and a value in a matrix is marked with both square and a circle, we got a solution. Hence, we got the saddle point, which can be called as value of game. The saddle point is the position of the value. As you can see, both are 2. So we get 2, 2. And the value of game will be VRS. That is V22. And the value is 0. Therefore, strategy of player A is second. And strategy of player B is also second. Thank you. Example 2 will be explained by Danish.
Let's move on to example 2 for better understanding. Payoff matrix. Maximize player A, minimize player B. We will check whether we will get the optimal solution or not. So the first step we will be doing is checking the minimum value of the row. The minimum value of the row 1 is -4, row 2 is -8, row 3 is -7. The maximum value of these row are -4. The second, we will be checking the maximum value in the column. The first column is 6, second column is -5, third column is -8. So the minimax value of these columns are 5. So the minimized value is 5 and maximum value is -4. Both the values are not same. So the saddle point in the table not same. Because of saddle point, we cannot find the optimized solution of the matrix. Therefore, such games are said to be the games without saddle point.
Thanks for watching. Make sure to like our video, share it with your friends and subscribe our channel.